Hello, class. You can only see the top of my eyes. This is Sunday, bad hair day. And we're going to learn about average value. This is going to be the video that just explains what the formula for average value is. So I'm going to share my screen here. And I haven't figured out how to not share my video, but I'm just going to let you look at that little tiny me in the roof. But all right, sorry. This is going to be my first video, so it might not be great. But if we want to find the average value of a set of numbers, we just add up those numbers and divide by how many there are. So here, we want to find the average value of all the y values on this curve from A to B. Now, in order to do that, we're going to be adding the f of the y values. So we need to split this up again. X sub 0, x sub 1, x sub 2, x sub 3, all the way down to x sub n, like we do everything. So we're going to be adding up all the y values at those subintervals. So I'm going to have f of x1 plus f of x2 plus and so on, all the way down to f of x sub n. Now to find the average value, remember we divide that by how many there are, which happens to be n of them. But remember, this is just a finite number. And what we really want to do is we want to take the limit of this as n approaches infinity, because there are infinitely many y values along this curve. So, and I apologize for my handwriting. So what we're going to do here, you'll notice, I'm going to go ahead and rewrite this in sigma notation. So limit as n approaches infinity of the sum as I goes from 1 to n of f of x sub I, and this is again divided by n. Now this almost looks like the definition of an integral right here, the limit of the sum of f of x. And what we're missing here at the back end is a delta x. So we're going to try and figure out how to get a delta x there. And since n is approaching infinity, maybe we can get rid of that n by just remembering what delta x is equal to. Remember, delta x is always equal to b minus a all over n. So if I try to maybe solve for n, I'm going to multiply the n over on this side, and that's going to be equal to b minus a. And I'm going to get n by itself by making it b minus a over delta x. If I substitute that in for the n value here, I would have limit as n approaches infinity of the sum as I goes from 1 to n of f of x sub I divided by b minus a over delta x. Now, nice kids I have. That was about, it was a long time ago. Anyway, so we're going to invert, right, and multiply. That would get rid of this. And if we look at what we have on the top here, what is on the top here is actually the definition of an integral. So really what we have is we have the integral from a to b of f of x dx, and then this divided by b minus a. Well, this down here is just a constant, so we're going to pull it out in front. And so we're going to have 1 over b minus a times the integral from a to b of f of x dx. And that is equal to the average value of f on the interval a to b. I appreciate you watching and listening. We'll see how this video turns out. I need to do something. I need to stop sharing. That's what I need to do. So I'm going to stop sharing. And then I'm going to stop recording. So again, thank you for listening.